In search of a rim shape that enhances aero balance and structural performance, Zipp advanced development engineers looked outward to nature, to its elegant, efficient, and complex designs, where every fiber and contour is purposely shaped, evolving to not only adapt, but to thrive. Pairing this newfound inspiration with precision engineering, the Zipp advanced development team reimagined the aero wheel, and in the process, developed the fastest rim shape Zipp has ever produced. Introducing the Zipp 454 NSW, a wheel that is both fast and stable regardless of prevailing winds. The 454's radical sawtooth undulating rim shape simultaneously reduces aero drag and side force for ultimate rider confidence and pure performance.
All of the rim shapes on the market, both our own and competitive, have high side force and low aerodynamic drag, and others with higher aerodynamic drag and low side force. And what we wanted out of that was to reduce both aerodynamic drag and side force simultaneously.
Achieving lower side force and lower drag at the same time is a challenge because typically as the rim profile gets deeper, it creates more surface area for the wind to act on.
We knew that the best adapted solution wasn't going to be intuitive or something that we could fall back on our past experience to create.
We decided to take a step back and try and come up with a new shape that will give us a little bit more of an edge.
What we did with this profile was we started noticing throughout this field of biomimicry, if you just look to nature, most of these complex problems have already been solved.
The humpback whale has tubercles that allow its fin to be more effective when it's taking sharp turns to corral krill.
We saw that and we thought, that's a similar thing that we're trying to do with wheels. So what can we do? How can we mimic the tubercle behavior and the features and put it on a rim to achieve the same sort of stability and efficiency?
The only difficult part that we had was to take a flipper that's supposed to work in straight flow to a wheel that is rotational while you're also getting straight flow over it.
What we were doing is really using the kind of profile of our hyperfoils to keep the air attached in certain regions.
A good way to explain what the hyperfoil does is to first imagine a vortex generator. You might have seen these things, they're pretty prevalent on commercial airline wings. If you look out the window, you see little tabs sticking up, and they're slightly askew from the wind direction. And what that does is it creates a pocket of low pressure to one side, which in turn makes a streamwise vortex of air that energizes the boundary layer, and that serves to keep the flow attached to the surface. Now, with the hyperfoil, it achieves the same thing, but it's one step more sophisticated. As the wheel pitches in yaw, the hyperfoil node becomes more prominent into the boundary layer and effectively creates more mixing and more energy transfer to keep the flow attached to the rim surface.
The undulating sawtooth RS shape with hyperfoil nodes stabilizes handling in gusting wind by increasing the frequency of wind vortex shedding. Lower frequency shedding produces larger, more powerful vortices, providing an unstable situation often referred to as buffeting. Higher frequency shedding produces a greater number of smaller, less powerful vortices, leading to greater wheel stability and rider control, saving watts typically expended trying to hold a line.
The dimples are hexagon-shaped instead of our traditional circular shape, and the harsh transition from one corner of the hexagon to the next makes for more effective mixing of that boundary layer.
And thus, curating a very stable, predictable platform. When you're designing, especially out-of-the-box stuff like this new rim shape, it starts with a hunch, and it really takes a lot of perseverance. We've tried many different profiles over many different tests. Each time we learn a little bit more about how it works and how it doesn't work.
During the development process, we not only looked into wind tunnel data, but we also wanted to model this using some more modern day technologies.
We just went crazy in the wind tunnel with all the different iterations, new design ideas. We dove into CFD to try to understand what was going on and how we could harness this concept.
But we also brought in another element, which was real-world testing. So we had an aero stick.
Over the years, we've developed a lot of our own proprietary aero sensors that allow our test rider fleet to basically go out, do tests with different profiles, and kind of give us real-world feedback.
And it's showing us that the position changes from crosswind really have a significant impact in the overall CDA or the overall speed of the rider. This is something that we really couldn't quantify before we took this to field testing in the real world, and we're showing that really stability has a tangible speed component or a tangible effect to your speed.
We saw the results, and initially we went back and reran it. We reran everything to make sure that it wasn't an anomaly, because we just achieved something that hadn't really been done before. So we wanted to make sure it was legit, and it was legit.
For unmatched stopping power and modulation, regardless of weather conditions or the length of the descent, the 454 NSW also features Zipp's industry-leading silicon carbide showstopper brake track. The final touch. Zipp's Impress NSW graphic technology prints visually stunning graphics directly on the rim and allow the finely tuned Hexfin ABLC dimples to fully function without obstruction. Making use of the NSW exclusive cognition hubset, the 454 NSW rolls efficiently whether you are pedaling or coasting. Zipp's axial clutch technology allows the free hub's ratcheting mechanism to deliver half the mechanical drag of conventional 3-pawl hubs. Assembled with Swiss bearings, made to exact specifications, the Cognition hubset is as robust as it is fast.
We're going after every single nook and cranny. No stone is left unturned to make this a faster wheel.
The 454 NSW Carbon Clincher goes beyond what was thought possible with conventional aero wheel design to usher in a new era rooted in stability and unrelenting speed.
The 454 NSW really started to tap into that rider need of needing a faster wheel and needing it to handle better. That is something that we've tried to accomplish for many years, and we're finally doing it.
This is the shape of things to come. This is the 454 NSW.